Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today, step 1, step 2, step 3, step 4, and your challenge is to determine the number of these little line segments in step 5. If you can do that, can you determine the number in step 43? And can you write an equation that could be used to predict the number in any step at all? That's the challenge. If you'd like to accept it, pause the video, see how far you can get. All right, so this I think is a very interesting pattern visually. We sort of have these, well, circle-ish polygon shapes made out of line segments, and then the old one is sort of left there, and we add a new one with the old one mostly inside it, but sharing part of the side. So it gets bigger and bigger. Right off the bat, I'm going to predict this is not linear because the amount you have to add gets bigger. That part of the perimeter seems bigger from step to step. So I don't think this is going to be a simple linear equation. Probably quadratic, but I'm not sure exactly what it'll look like. I think I can predict step 5 accurately, though, just by looking at the pattern. So we're starting with the previous shape here and then drawing that sort of new perimeter. So yeah, you go starting from here, you'd go down and then over and then across, and yeah, okay. So I think I can do the same thing on step 4 to get step 5. Let's try that again. So down and then diagonal. So I'm going to kind of follow what they did in step 3, down and then diagonal and then over. And we're going to go over further than step 3 because you want to go over until you've covered that diagonal above. So that would be there. Then we do a diagonal, and those diagonals are sort of parallel to each other, so that makes sense. And then we're going to go up, 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 and that should be the same number up. And then we do the diagonal over, whoops, and then connect at the top. Okay, so I think that's got it. Yeah, I'm pretty sure. Let me count segments here. Actually, this is going to be kind of the hard part, is actually just counting and not losing count. Let me start with what I've actually I'm going to start with the perimeter of this whole thing, the outside first. Then I'll do the bits inside. So I'm going to start here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to start with the smallest one and work out. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So I think I'm getting 44 line segments for step 5. You definitely want to double check that. In fact, I think what I'm going to do next is do the counting for all of these and look at the numbers and see if 44 actually makes sense with the other ones. If it doesn't, maybe I'll go back and recount. But let's make a chart with the step number and the number of line segments in each step. So in 1, we've got 4 segments. In 2, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And in step 3, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And in step 4, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. And we're predicting, in step 5, we're predicting 44. So let's take our differences and see if this 44 messes things up or not. So 11 minus 4 is 7. 20 minus 11 is 9. Okay, I think I see what's going to happen here. 31 minus 20 is 11. And 44 minus 31 is 13. So this is looking like maybe I counted correctly. This is not a constant number. We predicted that this would be quadratic, but so let's take the difference of the differences. 9 minus 7 is 2. 11 minus 9 is 2, and 13 minus 11 is 2. So there's our regular pattern. It looks like the 44 is correct. We've got a quadratic, and x squared is our leading term. But figuring out an equation for this, not that easy. Visually, I'm not getting much of a hint from this. It doesn't make a whole lot of sense. It doesn't tell me where the x squared is and what else there is here. It's possible there's some addition and subtraction going on, and that always makes things a little more complicated. All right, so here's what I'm going to do. Since we know our leading term is x squared, I'm going to make another chart here. So here's our step number. And this is going to be the segments again, but I'm going to write them in a different way, and we'll see if we can make any sense out of them. So in step 1, we have 1 squared, and what's left over then would be 3. Okay. In step 2, we'd have 2 squared, that's 4, and then what's left over would be 7, because 4 plus 7 is 11. In step 3, we would have 3 squared, so that's 9, and 11 left over. Oh, okay, I see how this is going to go. Let's just do one more step here so I can show this as clearly as possible. And so in step 4, we've got 4 squared, that's 16, and that's 15 left over. Now, we're going to look at the leftovers. We're building an equation here, and we've already got our x squared, our step number squared. How do we express this leftover part? Well, we're going to analyze it the same way we would our original numbers from the pattern. So let's take the differences. 7 minus 3 is 4, 11 minus 7 is 4, and 15 minus 11 is 4. So we're getting a constant. So the way to express this set of numbers is with a linear equation. So y equals mx plus b, and our m is going to be this rate of change, this difference for each step. So we would have 4x. And then what's our plus b? Well, we're going to go back to step 1. In step 1, 4 times 1 would equal 4, but we've got 3, so we need to actually subtract 1 to get down to 3. So this chunk is going to be expressed by this. So in building our equation, we have the step number squared, then we have this chunk to express the leftovers. So y equals x squared plus 4x minus 1. Yeah, I don't think I would have arrived at this by gaining any kind of visual insight on the pattern. The only way for me to get there was to analyze the numbers like that. Let's test this, make sure it's working with at least a couple of steps. So in step 1, it would be 1 squared plus 4 times 1 minus 1. 1 squared is 1, minus 1 is 0, 4 times 1 is 4, we have 4. So that checks out. Let's try it with 2. We won't do all of these, but we'll try it with one more. 2 squared plus 4 times 2 minus 1. So that'd be 4 plus 8 is 12, minus 1 is 11. Yeah, checks out. So I think this equation is working. You can test it with steps 3, 4, and 5 if you like and double check, but I'm pretty sure we've got it. So what remains then is to calculate the number of segments in step 43 by plugging in 43 for x. So that's going to be y equals 43 squared plus 4 times 43 minus 1. Okay, 43 squared is 1849. And 4 times 43, well, 4 times 40 is 160. 4 times 3 is 12, so 172. So plus 172 minus 1. And 1849, so this is 171. So 1849 plus 171 is going to be 2020. All right, so there are 2020 line segments in step 43. Well, how did that one go for you? I think this one is actually wicked hard. Did you get 44 for step 5? If you did, kudos to you. Did you actually come up with this equation? Then pat yourself on the back. Let me know how it went. Thanks, everybody.